As the day moves on, I think we're getting closer and closer to the marriage of human and machine, and I think our next session is going to just show you the differences between us and the digital human is actually getting smaller. So to introduce our session and to moderate this, I'd like to introduce Dr. Allan Miranda. He is the head of JLABS over here at the Mars 2 Center, home of actually one of our session speakers, Pentavere. So Dr. Miranda, would you please come to the podium?
Thank you, Tracy. Good afternoon, everybody. I'm Allan Miranda. I'm the head of JLABS Canada. JLABS is Johnson & Johnson's incubator here on the Mars complex. I am hosting this panel, and I'm actually, by training, an in vivo pharmacologist, so it's strange for me to be hosting a digital platform, or a digital session. But increasingly, as we look across the life science sector, and specifically pharmaceuticals and medical devices, increasingly we're seeing innovation in digital technology help us deliver products better to patients, help us give us better outcomes or better insights on patient outcomes. We're seeing a lot of digital technologies used in clinical trials, both in the implementation of those trials, but also in curating data to help us identify patients who can be used in trials. I know we've seen some innovations, not ourselves, but through partners using digital technologies to help us interact better with patients and caregivers. And when I look at the panel today, I see companies or individuals who can speak knowledgeably to all aspects of that. And so I'm going to get started. I'm going to introduce Aaron Leibtag from Pentavere. Pentavere is also a JLABS company, and Aaron has a very interesting background. His background is retail. He comes from a family of entrepreneurs, but had a very interesting background in retail, working for companies such as Danier Leather and Canadian Tire, and so he's had an interesting journey to where he is with Pentavere, and hopefully he'll share some of that story, if not during his talk, then during the question period. Aaron's company, Pentavere, has been in existence for about 2 years now, Aaron, 3 years? About that? 2016, and they're really focused on using natural language processing and other tools to take unstructured data and make it structured. And I think Aaron has come up with some very useful case examples in terms of the collaborations he's doing to show how that technology can be valuable in the healthcare setting. And so I'm going to turn it over to Aaron to introduce himself, but also Pentavere, and tell you why you should be interested in natural language processing and how it can impact patients. Aaron.
Thank you, Allan. Perfect. Oh, it looks like, let's try this. There we go. So if any of my investors were in the room, they'd probably kill me right now, because what I'm going to do is I'm actually going to skip through the slides on my company. And for anybody who wants to hear about my background's retail, but really finance. My evolution was really understanding how analytics and data and insights connected with the right people, the right culture, the right strategy can really yield results compared to you can have the best technology, but if you don't have those insights and it's not connected to great people, great strategy, great vision, you don't get those great results. And the reason I'm going to skip over about my company, because what I'd like to start doing in the spirit of our conversation today is talk to you about a serious problem that's affecting everybody in the medical and healthcare community. We hear about this problem from healthcare professionals treating patients, from hospital administrators, from researchers, from machine learning engineers and data engineers who are looking and require high quality row and column structured data in order to train their models, in order to get a better prediction out of their models. And I have a slide here that says this is the vision, but reality is far from that. This is the printout of a single patient's electronic health record from Princess Margaret Hospital. I'd like to thank our partnership with Luke and Tecna that we have a separate data sharing agreement in place that I'm even allowed to share this with all of you. But this is one patient's 5-year history with lung cancer. 153 pages of clinical notes, histopathology reports, transcription text, and despite everything we read and hear about in machine learning and AI today, despite everything that we see in terms of the vision we've talked about earlier today, if we want the information that we need to be better at what we do. And in healthcare, that's serious because it's not just that we're going to leave money on the table. It's not just that we're not getting efficiencies, but it impacts people's lives. So to get at the information that's in here, histology, treatment protocols, reasons for continuation and discontinuation of treatment, patient comorbidities, patient outcomes, we hire individuals and teams of individuals to manually go through charts like this on a screen and pull out the information that we need. It's extremely expensive. It's extremely time-consuming. Accuracy is hit and miss. It's not scalable, nor is it reproducible. And what I'm going to be sharing with you is, if you think about technology and innovation a little bit differently, and these ideas are not my ideas. These ideas actually come from a book by a number of U of T professors called Prediction Machines that says, if you think of technology not in terms of innovation, but how it reduces the cost of things. And when you dramatically reduce the cost of activities, how does that impact the vision and destination that we'd all like to get to? So what I'd like to do is not show you some PowerPoint presentations, but actually share with you our technology that replaces or augments manual chart review without having to incur the cost, time, and inaccuracies of manual chart abstraction. Everybody see my screen? This is our engine. And what I'm going to be showing you is, just to start off, is I'm going to be copying and pasting a paragraph through. Although this is a mass paragraph, it's fairly representative of what we call unstructured data in healthcare. It's deep in clinical information, it's got spelling mistakes, it's got a whole whack of information. And this is the type of narrative that if we want to create meaning from, if we want to leverage, we're going through the electronic charts to put it into some type of control report form. I run that through our engine, and immediately in real time, we get high-quality, structured row and column data. And that's at the core is our product. We don't have slicing and dicing visualization. We're not a prediction shop. But what our product is high-quality, research and evidence grade, positioned to eventually become regulatory grade row and column data sets. So if we think about this now as an Excel spreadsheet where each row is a clinical feature and each column is a property of that clinical feature. So we can see we have information on patients, we have information on locations, labs. If I just scroll to the right, what we can see is we've got a male, 72 years, from South Africa with a risk factor of non-compliance. Where's the source of this? 72M South African. Talks somewhere down here about history of non-adherence. And what's really interesting about this concept of social risk factors is this came out of the early validation and clinical work we did at St. Michael's Hospital, where we got feedback from clinicians that said socioeconomic factors matter. If a patient is dealing with food insecurity, underhousing, they're going through family stress, I believe that impacts how we treat them, that impacts how they adhere to treatment, and that impacts what their outcomes are. But to get at that information, there's no data set or registry that collects that information. So as a function of that, we built in the ability to extract clinical features. Now, once the data is in row and column data sets, and I'm boiling the ocean here, and I'm going to explain to you in 1 second what that means. But once it's in row and column data sets, you can do anything with the data. So what I'm going to do is I'm just going to reorganize it in the structured medical record format we're used to looking at to highlight functionality of the engine. Because it's not enough just to extract out a clinical feature. We need to understand the context associated with that clinical feature. That particular diagnosis, does the patient have it or not have it? Do they have it now, or is it being noted as history of? When is that diagnosis or clinical feature occurring? Is there uncertainty associated with that clinical feature? So you can see here we talked about there was an EKG. Normal happens to be a coded modifier of that test, but I'd like you to pay attention to the dates. Notice this says September 2018, this says November 2018. Well, what's the source of that? In the absence of all other information, we'll take the data the clinical note as current, but you see how it says here, last seen by his cardiologist 2 months ago, EKG normal, LVEF 35%. So what the engine will do is it will recognize 2 months ago relative to the date of the note, and it will code that as such. I talked about Concepts like polarity, uncertainty, history of, who is the subject? Does the diagnosis belong to the patient, or is somebody collecting family information? So we can see here, for example, if I go back to the note, we have a whole bunch of information. Note, father has heart disease, PTHX of fainting, unsure of nausea, no vomiting. So if we extract out those clinical features and add the context to those clinical features, what we see here is we've got heart disease. It's positive, but it's not the patient, it's other. There's a history of syncope. Remember, PTHX of fainting. Vomiting is negative, does not have vomiting. Now, the reason I'm showing you this in terms of extracting out all of the clinical features is because to highlight functionality of the engine. But we all know that real-world data doesn't look like that. So what I'm going to do is I'm actually going to run 5 records like this through our engine. And it's going to take a few minutes to process, but just to give you an idea in terms of the scope of 5 records. Just in 5 records, so 5 patient records with lung cancer, there's 17 pathology reports, 348 distinct clinical notes, and 436 imaging reports. And if I go back to my PowerPoint presentation right here, we're not boiling the ocean, and that's not how we work, because we define and extract clinical features that can be used for research, has been used for research, has been published against. So what the engine right now is consuming is extracting from all of that content these 26 features. And let me just talk about the nuance of that, because anybody who does research in oncology often sees, okay, what's the ECOG status at stage 4? But in reality, we all know that the data of the ECOG and the data of the staging aren't the same. So if you have a manual reviewer going through the records, it poses some interesting questions in terms of what we consider truth today. Because is the manual reviewer pulling the last ECOG before the staging? Are they pulling the first ECOG after the staging? What happens if a manual reviewer is recognizing staging from a standpoint of histology? So you can have variability of a single reviewer looking at multiple charts, or multiple reviewers together on a single research project looking at a number of charts. We define that rule precisely up front. We measure and validate against that rule. Going back to see in terms of how the engine's processing, you can see it's starting to generate tables. But I'd like to just look at what the state of that data is. Because you can imagine in lung cancer, smoking status is important. Did that patient smoke? Well, what happens if there's conflicting information, or what is the rule that determines if the patient is a former smoker, a current smoker, or a never smoker? And if we just go through this one record, which is a real record, and I just go smoke, okay, it's an ex-smoker. It's a never smoker. So very, very easily that manual reviewer can say, oh, it's a never smoker, lunch is 10 minutes away, there's another 40 charts I need to get through during the day, and that never smoker is the actual clinical feature that goes into the control report form or becomes part of the registry or part of the structured data that will then go and inform a predictive model down the road. What we do is we define the specific rule, and what the engine does is it will extract all mentions of smoking based on the linguistic nuance associated with that word and the rules we've set, and then make a call. So just to give you a concept in terms of the scope of the data, as we start scrolling down, you can see date of diagnoses, date of death when available, histology, age at diagnosis, location of metastases, biomarkers and biomarker expressions, other comorbid conditions. Going back to that smoking example correctly, because this was actually validated and there's going to be a manuscript published on it, this is a former smoker with 30 pack years. ECOG status, all the various ESAS scores, all extracted and structured. Now, as I mentioned to you, Techna's been a wonderful partner, but going back to that concept of when the cost of data curation is so high because it's manual, not just high in terms of cost, but high in terms of our ability as humans to go through content like this and pull out the features that we need in order that it can be analyzable, in order that it can be meaningful. We've become accustomed to registries of 200 patients per site, 300 patients per site. We aggregate that together, multiple sites, and we're looking at an end of a few thousand, and that is a huge data source. At Princess Margaret right now, in terms of lung cancer, think about this being a row and column data set that is all the asset of the healthcare provider, this is just 5 patients. Imagine that being 1,000 patients. We're deploying right now at the provincial level in the province of Alberta. So I'd like you to imagine, as we start thinking about big data and the promise of using data to create that digital human, imagine a data set just in one province of 10,000 patients being able to collect this type of information, where before that, how did we get at it? Through individuals and teams of individuals manually going through charts to curate the information. So going back to where we play in the overall value stream of our journey towards the vision that I thought was so well articulated this morning, is we're solving the problem about the curation of data that we believe good AI, good science, good research, good predictive models starts with good quality, high-value data, and the degree to which we can reduce the costs and barriers associated with curating that data as a company is how we believe we're going to make our dent to try to be a partner in that vision that we're going to be talking about today on a panel, and I think the theme of the overall symposium today is all about. So thank you so much.
Thanks, Aaron. I'm going to go off script here because the Slido questions are up there, and there's one that caught my eye. So just before we have Dr. Grasso come up, there's a question about the structure of data and the FDA and what they would look at is data versus some of the data that you're developing. What is the gap between what you're developing and the ability to submit this for a regulatory submission, or at least as background information that FDA would consider in approving a product or moving forward with some sort of clinical trial documentation?
Yeah, it's a great question. And I was just with Health Canada on a 2-day sprint about 2 weeks ago or 3 weeks ago talking about this. So the FDA is actually acknowledged the need of real world evidence and are in the process of publishing guidelines, coming up with guidelines, and Health Canada as well is open to real world evidence, both for use in clinical trials and for use in value and reimbursement discussions. What the exercise right now is if you think about some of the activities of Flatiron or other companies like that are doing in the States, is they're extracting population cohorts from real world evidence that mirror the population cohort of a clinical trial. And they're attempting, in some cases successfully, to reproduce that clinical trial in the real world evidence data source and compare and contrast the two as justification and that journey to build credibility towards real world data being used for regulatory filings to make it regulatory grade. We attack the problem a little differently because if you think about whether it's a retrospective observational study or data going in for a clinical trial, people are still manually going through charts to put that information into whatever approved documentation that should go. So what we're super focused on is replacing and augmenting that process in the value chain and ensuring we have the transparency, the audit trail, all of the current controls that are in place in the manual curation as part of our technology to help with those regulatory discussions. And we're doing that so when the FDA does decide and when Health Canada does say, here are the guidelines for RWE to be used, we're going to be well positioned to be able to say, here's a tool that can realize that vision.
Okay. Thanks very much, Aaron. So thank you for that. I did also asking that question. I wanted to know we are up on Slido, so if you have questions for the presenters, please submit your questions. I see a lot of you with your phones out, and so I presume you're diligently asking questions on Slido. If you're surfing the net, then you can also put your hand up and let me know whether Frederick Anderson is going to start tonight or tomorrow in the game. Okay. It's an inside joke. You want to switch. There's a switch going on. We're calling an audible. So we're going to move forward. Tyler is here. His company, UneeQ. I'm not going to say it wrong. How do I? UneeQ. UneeQ is doing some interesting things in terms of chat box and chat box technology. I think we've seen a lot of companies focusing on being true to the word and understanding words and phrases and getting better at the fidelity around that. His company is spending a fair amount of time trying to understand emotions and how we put emotions into chatbots so that patients, caregivers, others can have a real emotional experience. I think from a customer perspective, have a more fulsome experience. So Tyler's going to tell us a little bit about that. Tyler is a background in IT sales, engineering, he calls himself a technological evangelist. I was going to dig into that later on, but I'm going to let Tyler tell us a little bit more about UneeQ, and then we'll talk about his evangelism later.
Hey everybody, good afternoon. Love the passion. It was amazing, woke me up. At UneeQ, we are all about digital humans, okay? So what is a digital human? Here's an example. Sophie, as we call her, is one of the first digital humans we made starting in 2015. And everything we do is about emotions, okay? I heard some great quotes this morning. There was a gentleman over here that presented in the keynote that said the image of the avatar was a little bit awkward. He made the comment that a bunch of people kind of giggled a little bit. There was a comment about how to do a UI and a UX, and there's all these people that are going to school to learn about design. Well, this is the universal UI, right? We implicitly understand how we're feeling without even knowing language. Babies respond to their mothers, dogs respond to their owners. It transcends our species. So we are all about the emotional connection, and that's going to feed into healthcare. We'll show in just a second. So Gartner says by 2025, 85% of interactions between consumers and the services or products that they are engaged with will be automated. It's going to take over healthcare. It's going to take over finance, travel, anything you can imagine. We're going to get there, okay? So that's the problem statement. If it's going to be automated, how do we deal with the research that says unless you have an emotional connection, you are going to drive people away from your practice, right? And we are here in Canada. You guys have a different health system to the US. I can tell you in America, it is a product. We are a product of our system. So I get to choose my doctor. I get to choose which imaging clinic I go to. There is a business imperative for these people to have an emotional connection with people. And there's all these ads on TV, if you've been down to the States, that talk about, we're doing our best at Baylor Health Systems to help you out. They're trying to create this, right? Outside of a normal, clothing line, Nike, Adidas, whatever, they're trying to create the emotional connection. Well, you can't do that when all you're focused on is the words, okay? So this chart up here breaks down communication. 3 elements, right? What we say, how we sound, how we look. You'll see that how we look, the facial expressions are 55%. This is not our research, this comes from academia. The companies that are focusing on natural language processing, okay, the Google, the Microsoft, the IBM Watson, they're focused on the 7%. They're all amazing engineers. I've heard tons of people up here talk about synthesizing information and understanding and generating text and things like that. All of that, super important. Don't deny it. But it's only 7% of the problem. So it's a math problem, which is why Google and IBM are trying to tackle it. They are taking enormous brain power in their PhDs and their linguists, and they're coming up with algorithms that can approximate human intelligence in terms of the content. But they're totally leaving out 93% of how we communicate. And now we have like SSML, if you're familiar. Google and a bunch of other companies have an open standard to try and make it sound a little more human. So your Alexa and your Siri and your OK Google and things like that start to have a very human sounding voice, and we like it. But in my house, I have about 9 Alexa devices, and she is a genius. She understands everything I say, and she answers all my questions. But I couldn't care less if one of those devices broke down, fell apart. My dog, on the other hand, is totally useless, doesn't do anything for me, gets all of our love and affection, right? The dog has the face, and it can go, what's going on, right? Does nothing for me, but it's like, oh, I love you so much. So we have to have an emotional connection, or it just doesn't matter. So, advance. How does this apply to healthcare? We were actually engaged with the government of Australia in 2015. Our company comes from the call center world. We were doing video conferencing solutions. The government went through a change in their health offering that was not unlike Obamacare, not exactly the same, but they needed to communicate a huge amount of information to their populace, and they thought the best way to do this for a customer service aspect would be face-to-face. So they wanted to have video conferencing solutions set up with their call centers. Well, The problem is nobody wants to be on camera, right? Video conferencing, video calling, these things have not really taken off because we're always worried about how do I look? How's my hair? I'm in my pajamas, right? I'm not wearing any clothes at all, whatever it is. So they made the comment, the government, right? What we need is not better video conferencing. What we need are virtual customer service agents. Ha, ha, ha. And that's where an entrepreneur goes, hold my beer. And we went and created it. So Nadia is one of the first digital humans that we created. And the cardiac coach is one of the videos we're going to show in just a second. So the problem specifically in healthcare is about health literacy, okay? All the solutions that have been presented here today, from my perspective, are operational, right? It's all about kind of empowering the system to do its work better, but hardly any of it really gets to the problem that the patients are hearing everything you're saying for the very first time, and they forget it right away. I had a procedure on my knee a couple years ago, and it was just, it's overwhelming, right? The doctors come in, blah, 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 blah. You have this problem in your knee. We need to cut you open. You're like, oh my God, sign here, 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 and here. You think, I might lose my house if this doesn't go well. So literacy, as intelligent as I am in software engineering, I'm an idiot in healthcare, right? I know nothing about how my body works. We need to educate people. And I heard the comment earlier that says, people love direct interaction and they want it to be more meaningful. The gentleman, I think Chris, that was in the wheelchair, was talking about how he wanted AI to handle the things that were automatable so that the nurses would have more time to get to know him. Well, that's probably not going to happen, I'm sorry to say, but we can supplant the human nurse with a digital nurse. And this problem of 232 billion can be reduced in some way as a result of that. So let's take cardiovascular disease. We have 70 million sufferers in the United States. You have two and a half, let's say, in Canada. Cost of that, right? We're looking at 208.8, we'll say 209. And the health illiterate population, right? 90 million of us in America. I have no idea, right, how any of this stuff works. Last science class we took was in high school. So we need to increase health literacy and build trust. And you only do that with communication. And the communication can't be rushed the way I'm rushing right now. So what is a digital human? Well, they're all about empathetic co-design. It's about creating a relationship that is over many interactions. You're not going to have one interaction with a digital human. You're going to have a relationship. And so we came from Nadia here. Skipping around. Slides are a little bit out of order. This is kind of how we do legacy health on the left, right? And how we kind of see the future with digital humans across these various mediums of consumption. So on the right, the digital human is your interface to the health system. It's not a website, it's not a pamphlet, it's not serve your own information via YouTube videos. It's literally someone to ask. Okay, so the whole concept of user experience and user design goes away when you have somebody to ask. Those things exist. Websites exist because there's nobody to ask, right? So the barriers there, of course, that we're trying to overcome listed here, right? We don't have the accessibility, especially in the US, since it's such a spread out, an enormous place, and we can't get to clinics and we can't have face-to-face conversations with people. We need to access this at home. We need to scale it up in such a way that none of the training or automation is going to fix the fact that the boomer generation is retiring way faster than professionals are coming into the industry. There's just not enough nurses. There's not enough doctors. There's not enough anything, especially in the United States. And I believe the problem is fairly similar statistically in Canada, although your system, is quite different than the way we have it. Only a digital person can do that. So here's an example of cardiac coach.
Oh, I'm okay, I guess.
You don't sound sure. Can I help you with something?
Oh, it's just these pills I've had since my bypass. I don't know what they're for.
I can help with that. Just hold one of the boxes up so I can see the label with your name on it. That pill or med is called a statin, Sam. Its job is to reduce the bad fats in your blood that can cause problems with your heart. It says on the label to take one at night. That's when they work best.
Okay, thanks, Coach. Talk to you later.
Okay.
I look forward to it, Sam. Make sure you get some rest now.
We saw a number of AI applications in that video, right? We saw optical recognition. He held up the box of medication to the front-facing webcam, and using very simple machine learning algorithms, we can tell exactly what is written on that package. And so we can then respond what that medication is for. This is super common in the United States, that people are discharged from hospital, given 6 prescriptions to manage a bunch of different things that could happen, and they forget exactly when they're supposed to take it, how many they're supposed to take, are they supposed to take it with food, with water, et cetera, et cetera, et cetera. And in the US, they go back to the clinic. They make an appointment so they can ask those questions. And that's one of the things that's slowing the system down, is this unnecessary demand on resources. So at-home care is better for everybody, right? Because he can ask the question a dozen times until he gets the answer, and doesn't take somebody else's slot at the clinic for the next appointment, if that makes sense. So we're building trust through that relationship, right? And one of the things that we're doing is working on emotional feedback back to the patient. So using the front-facing camera, if they look distressed, the digital human can respond empathetically. Are you okay? Those are the kind of things that words alone can't do. So the very last part of this is, and we jumped the gun here, but earlier in the day, is the video not queued up? Do I press it again? Yeah, please. Earlier in the day, you saw a blonde-haired avatar, I think, in the keynote speaker slide. This is what she looks like
while
now.
maintaining the highest level of service for the more basic requests.
Hello. Thank you for calling Amelia Healthcare. My name is Amelia. Please tell me your full name.
Megan White.
Thanks, Megan White. Are you calling
So I
to
think
make
you
an
can see,
appointment
if you
for
remember this
yourself?
morning,
No,
that
I'm
the
calling
difference
for
in
my son.
quality
He's
level
really
of the
sick.
And
polygons
what
that
is
went
the
into that
patient's
character
name as
versus
it
this
appears on their
character
medical record?
are enormously
Jack
different. And I don't think anybody
I
would
will
giggle
gladly
at
assist you.
that
Before
not
we
looking
continue,
real.
let me just
When
verify
we
the
produce
patient's
digital
identity.
humans,
What
we're
is the
producing
patient's
them
date of
at
birth?
4K
9/30,
resolution. It's
2008.
indistinguishable
Thanks
from
for
reality.
verifying the patient's
So
identity.
that's what
According
UneeQ
to our
does. We just
records,
focus on the
the patient's
emotional layer.
current
We
insurance
connect
is
to the
not
chatbot.
covered.
We
Is this
integrate
still the
with
patient's
other
insurance?
solutions.
Yes,
And
Based on the
we
patient's
think that this is
previous
sort of the
visit,
future,
I see that
one
your
of the
last
potential
follow-up is
applications of the
Grasso.
future of
Do you want to
artificial
schedule an
intelligence.
appointment with Dr.
Thanks.
Grasso?
Thanks, Tyler. Tyler unfortunately has to leave us, so he won't be around for questions. But thank you, Tyler, for your presentation. Interestingly, a couple of years ago, I had a company, as I said, I'm the head of JLABS Canada. I had a company come up to my office, and in the space of a few minutes, they took some pictures of me, and they designed an avatar of me, like almost on the spot. And I took it home and showed it to my wife with great excitement. And she felt that the avatar was more lifelike and believable than me. So it can go, technically, it can work against you. I wanted to introduce Dr. Vincent Grasso. Dr. Grasso is a surgeon by training, did his training at his surgical residency at Yale. While he's at Yale, he also picked up a specialty in informatics and digital technology. So Dr. Grasso has recently assumed the global life practice lead for IPSoft, where he is, I think, leading the implementation of their Amelia technology. I think we've seen a lot of these types of platforms. I think we see in the AI world, we have Watson from IBM. Amelia, as I understand it, is a platform that's being deployed in the hospital to help with patient flow, patient logistics, but much more than that. They are currently working on some very interesting pilot programs to kind of show proof of concept and other things in the opioid crisis and some other areas of healthcare. Looking forward to Dr. Grasso's talk to see about how they're implementing, what some of the challenges are, and what some of the scalability is of this technology. So Dr. Grasso, I'll turn it over to you.
Thank you, everyone, and I'm glad you got to see Amelia in the last presentation in the opening keynote. So that's our conversational computing front end, and it's a very interesting platform. And so I'm going to jump into this next slide. We heard about 2001: Space Odyssey. That was an interesting movie, and I was really impressed with Blade Runner when that came out in '91. And you never thought that John Rambo would say anything that was relevant to this conversation. But in Rambo 2, there's an interesting dialogue between Mr. Murdoch, the shyster CIA administrator, and Rambo about technology that was available to him to extract people from Cambodia. And he says something very interesting, that the mind is the best weapon. I'm a proponent of the mind is still being of massive importance as we move forward, and AI in its infancy really is a far cry from it. The image on the left is interesting because in 1997, the IBM environment did defeat Garry Kasparov, but it took 20 years for AI to defeat the world's best Go player, because Go and chess are very different games. And until the GPU processors really evolved, you couldn't defeat a master Go player. So this was a little disconcerting to me when the AI got that good, because it really was an massive exponential leap forward. I'm very involved in the combating the opioid epidemic in New Jersey. I'm still practicing. I'm a surgeon, but I did internal medicine too, so I'm doing now some family practice in an inner city clinic. And this just came out 2 weeks ago. The Society of Actuaries, $630 billion in cost over 3 years of what the opioid epidemic is doing to the economy. This is not just the US. This number is just the US, but this is a global problem. And it's not just healthcare costs, lost productivity, and people suffering in their homes, and going to jail or getting people out of jail, and legal costs. So it's a profound problem. It probably affects someone directly or indirectly in this room, and it's not an easy thing to solve. There's no magic bullet. And I think you'll see from some of the other slides of how we feel we can begin to address this. I think I'm hearing a lot of talk about people starting on an AI journey. This is a sophisticated audience. The average healthcare system is not really proficient in being able to go and select assets from this AI ecosystem to begin to deploy within their organizations. It's not easy. It's a very different beast. I have a couple little drawings on the right. No domain, one domain, two domains. The method to the madness behind that is if you're going to proceed on an AI journey, you can't have only one relevant stakeholder at the table. So if physicians think, and I'm a physician, oh, I have a really good idea to use AI. I don't understand the business consequence of it. I don't know how it will be integrated into a system, but let's proceed. No, that's really not that's not really a good exercise. The same with the tech people. Oh, I figured out how to solve this healthcare thing. Well, it doesn't work in the workflow that we use. Well, then change your workflow. Oh, no, I'm not changing my workflow. And the same on the business side. So if you don't have this volumetric approach to solving these problems with the right domain people at the table, business people, IT people, domain people, clinical, you will go down various paths of futility. So have them all there early, and you can do it. And there have been lots and lots and lots and lots of AI pilots, and very few go to full production. Some of them that go to production had massive amounts of funding up front to actually seed the project. That's not the same. So, you know, it's really valuable to have all these people up front early. Now, I transitioned out of full-time surgery about 12 years ago when I moved into the business and IT side of the equation. I was kind of adopted by Ted Forsman and some interesting investment bankers in New York. Teddy and Henry Kravitz kind of invented leveraged buyouts. So they're interesting guys. But Teddy taught me something on the left that I use every day, basically, when I'm making business decisions of how I deploy assets. And there's a very simple formula. Value equals relevance times validity divided by work. And when you deploy AI assets, you have to be able to make sure that what you're doing is relevant to all stakeholders. The output of what the machine gives you that you'll make a decision on is valid, because the question up there, what if it mixes up numbers, doses, and dates? If you can't assure that what you get is valid, the numerator has a very low number. And the denominator of work is, if I can do this faster and easier in less time, I have an advantage in a process. So relevance and validity divided by work is an interesting number. The maximum score, say, is 100. The lowest score is 1. So anytime I'm involved in something, I look at these three variables, and it helps me make business decisions. I think we also have to recognize that speed is a really bad term for when you're moving forward, designing and building and deploying, because it has no direction. It's scalar. Velocity has direction. So if you're not going to work with your other team members, you could go really fast on this path, but they needed you to go in this path. So you have to really get a sense of the velocity, because it has direction and amplitude. And Teddy told me, and I never really understood this until later on, business is demand, it's not sales. If there's no demand for something, good luck selling it. Good luck. So identify in your organization where there's the most demand, where's the big pain point, and you'll get people to rally behind you. And then you'll have the same vector. You'll be in the same direction. So these are just some little insights of of moving things along. So I'm still in clinical practice. 2 days a week I work in our clinic in Newark, New Jersey, which is not an easy town to deliver care in. It's a multi-specialty practice. I even do house calls. You'd say, why would you do house calls for? Because the house call is the battle space as we decentralize care from hospitals to the home. You got to drag everything with you. All the gadgets, all the IoT, all the bandwidth has to go out to the home. It's really hard. We see about 750 patients per week. Most of them are Medicaid. This is the working poor, the medically and economically disadvantaged. And I saw 25 patients on Monday, and probably 80% of the tasks that I did, I would call low-value tasks. Fetching data, look at this record, do this, where's the consult, why isn't the consult here, why are you here? I only have 20 minutes. You can't be verbose and go and recite a ballad. So simple and moderate AI solves a lot of those problems. The high-value tasks is where I should be using my brain to solve complex problems. I don't have much time. So this is where there's opportunities for simple AI insertion to solve some of these low-value tasks that are present. And the economic drivers, the socioeconomic drivers of opioid consumption and chronic consumption of care actually involves obesity and osteoarthritis and depression and poor nutrition, et cetera, et cetera. So when you have a cohort of patients that have all of these concurrent variables, good luck delivering care when you have only a small bucket of funds to dispense in that demographic. How do you ration all that money? How do you do that? So unlimited consumption of care really doesn't work. And we have to figure out ways to not ration care, but use the resources more wisely. So let's look at this opioid risk tool. Now, by the way, are there clinicians in the room? Good. Any lawyers in the room? So lawyers are really important in this equation because the lawyers that I know are very interested in AI because it changes the risk profile, right? It's hard to subpoena conversational computing agents. Where's the record to subpoena, right? So, and if you're a doctor or, if you're a physician and I write orders, I would like to know that my patient is exposed to a conversational agent because there may be some decisions made based on that interaction. So if I'm a doctor and I don't even know that my patient is talking to a conversational entity, to me that's not very interesting. That places risk to me. So physicians and nurses really need to be at the table as these things start to evolve. It's in their interest and it's in their legal interest because they sign the orders. So you're on the hook legally. So let's look at this opioid risk tool. This is from the CDC in the United States, and I'm sure it's here. If you're going to write a prescription for Percocet for a patient like I did Monday, 2 patients I had to put on Percocets, I'm supposed to have done this opioid risk tool first to assess their risk of abusing the substance. Low, moderate, high. So I'm going to go live in 2 weeks in our practice. I think we're the first probably clinic in the US in an inner city impoverished clinic where the physicians actually designed the AI use case and deployed it. That's rather interesting and unique. So in 2 weeks I go live. I'm going to take 100 patients to run this through. Now, that's pretty easy to do. 100 patients, we could do that in our small clinic. But Northwell Health, where I was a senior information architect in my last hat, has 10 million patients in its network. So suppose the underwriters, or suppose the risk department at Northwell said, you know what, I'd like to know what our risk assessment is for our patients. Do you have that report? I don't know, let me go check. Maybe I do, maybe I don't. How would you poll from 10 million people? What if you were told, I need 5,000 reports by next week? How would you do that? Would you call all the offices and tell the medical assistants, oh, the next time someone comes in that's on Percocets, get the test? No, you could never do that. So what you do is you deploy a conversational computing AI front end, deploy that across the manifold of users, and get your data back and generate the report. So you would take one task from a medical assistant and spread it out. There's no other way to do it. You can't get that report. What's the report worth? Wow, it may be worth a lot of money getting that done in 2 weeks. So that's where there's demand, right? So, and I'll share this report with you guys when we complete it. So the evolving medical assistant, I heard some interesting discussion before about how we're going to get AI into the educational frameworks. I met 2 days ago with the president of a very large community college in New Jersey. I've written curriculum for universities and stuff. We're figuring out how to change the curriculum for medical assistants to include AI as a mentoring agent, and as some entity that would allow a medical assistant to enter a clinic faster and have the AI keep them honest by managing the care plan with them. So there's about 2.5 million new medical assistants that are in demand in the US as the population ages and they have chronic diseases. How do you train all of them? How do you get them going? So on the right now they're organic labor. There is no silicon labor for doing medical assistants, all the things they do. So there's a hybrid labor pool. So if you can take the 100 tasks that medical assistants do and have 5 of them done by a digital employee, you've eliminated some of that churn, and as we heard from Terry before, the burnout of healthcare providers doing things that they feel are redundant and mindless. So this is where things start to evolve and get interesting, and it's got to be done at the grassroots level to train these folks. Horrible stats we know about the opioid epidemic, people suffering, people dying. In New Jersey, it's a staggering amount of people that are succumbing to this disease. They die kind of in the end of the stage. They don't just die after the first consumption. So this is rather sad. And there's 3 phases of opioid use: prior, during, and after. So the patient that I had to write a Percocet for, they already had chronic pain. They were taking Motrins. We tried everything, and they got all these complications of NSAIDs. So that's prior to the consumption. Once you're on it, there's the delta of being on it. And then when you are, fortunately, if you can get off of it, how do you decrease the relapse, the recidivism? So if you're going to approach the opioid epidemic with one use case, good, that's a game. You have to be able to look across this whole manifold and have a plan of attack of how you're going to do that. I'm going to skip that for a second because we're running out of time. We know also that if you consume alcohol and tobacco and other things, really hard to get off opioids. There's direct correlations with that. So let's jump into I said the EI ecosystem before, because people say AI a lot. AI will do this, because I saw examples of very different parts of the AI ecosystem. Conversational computing is front end. Chatbots, Alexa, Amelia, that's the conversational front end piece. RPA is a completely different piece of that. And machine learning is another piece. So it behooves us to, when we talk about AI, well, what part of AI are you talking about? Oh, it's the same. No, it's not the same. It's a category. So conversational computing, and depending on the sophistication of the cognitive agent on the right, so Amelia has a lot of depth in understanding semantics and episodic memory, and she has process memory. She can understand BPMs, business process flows. And she has an effective memory. That's very interesting. Chatbots generally don't have that sophistication. So conversational agents go from chatbot simple to rather complex. RPA is wildly of use in managing process within healthcare that are workflow dependent. When I order an orthopedic consult on someone, I have to click 6 buttons in an EMR. I have to click consults, ortho, this. I should be able to execute that in RPA. Ortho consult, Dr. Jones, right knee pain, verbally. Speech to text, parse it, execute it. So that's RPA. And then the machine learning side is interesting because it's stuff that we've seen. Rip through these large data sets, get us some information, some insights that we didn't have before, and then what do you do with it when you've found out what to do with it? It influences upfront process change. So one of the interesting features of this ecosystem, this is a certain level resolution of a large VNS, Visiting Nurse Service, revenue cycle management framework. Look at the stakeholders on the left: office clerks, nurses, billers, office managers, CAOs, CTOs. And there's a process of getting information, validating insurance, blah, 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 as you go through. People that are on opioids, there's a much higher complexity of managing them. They miss appointments. All of a sudden, they have constipation. The visiting nurse goes to see them, they have abdominal pain. Do you go to the ER? What do you do? The patient complexity changes dramatically. It impacts revenue. How do you deploy your resources? So if you can't map things out in a proper business mapping format, it's hard to apply RPA and AI to it because you don't know your process either. So get really good at building BPMs so you know your process really well. And then it's easy for people to come in and say, the conversational computing thing you just saw could ask you your insurance information and validate it. You don't need a human for that. Use cases: multilingual, multimodal, omnichannel. Humans are not omnichannel. Humans are not multilingual, unless you are, but most of them are not. So this is some of the attributes of a powerful conversational front end that could do appointment scheduling, care plan follow-ups, frequently asked questions we heard before. How about RPA? RPA really works in process automation, right? So and all the complex processes that you have can be addressed in some part by RPA. And then the machine learning stuff is really the sexy, interesting stuff, right? Look at this data. What insights did you get? How would I change my care plan? But you can see that this is an iterative process. Figure things out on the machine learning side, feed it back to the front, make your changes. It's tweaking. It's constant tweaking. It's an iterative, agile requirement. So I'm looking forward to talking more later, and thank you for your time.
So thank you, Dr. Grasso. As your last, whilst you were talking, you talked a little bit about demand and sales. So I think the counterpoint to that, sometimes people talk about interoperability. I think more when I think about physicians is they usually use AI or other tools, digital tools, as a post hoc validation of what they've done, but very little change in their practice. And so whilst they're aware of AI, may acknowledge its utility, very little actual utilization. And so you talked about a setting in opioid crisis where there's constrained resources and that kind of necessitates. So what are some of the things that were, I guess, what's preventing these types of tools from being used more widely? What's the big challenge? Is it technical? Is it business process flow? Is it cultural? What's the barrier to it?
So in the demographic that I represent in Newark,
You can pick it. I think one of the microphones should be.
hello?
Yeah.
One of them is linguistic barriers. Probably 80% of the patients in my practice don't speak English. You know, I speak Spanish, so I'm able to communicate. But if you have the starting point of an uneducated audience that's linguistically challenged, unless you have a development team that's going to build this process in Spanish and change the UI to meet the demand of those patients that may not have really good smartphones, they don't have good internet access at home, how do you deploy that? So there's a technical challenge. I have from patients that I've polled, I have wild interest in people that feel, I wish I could talk to somebody that could answer a question. I know you don't have any time. Very happy to engage in this. I don't have pushback from that audience that oh, is it secure? They're very happy and looking forward to engaging. So that barrier seems to be a lot lower than I thought.
Okay. You talked a little bit about language, but language is one small part of culture. How do these tools scale across different cultures where things like power dynamic issues around how much I share, how I share things, how does that differ with a virtual agent versus a real physician who may be from the same culture, may be able to nuance their questioning? How do these tools apply in that kind of context?
I've done a lot of international care, so I'm taking the approach that I'm your doctor, so there's some trust. I'm going to walk you through what's going to happen. I'm your shepherd through this strangeness of AI. And by having a good rapport with my patient, they trust me, and so long as what I do works and works correctly, I can do the second thing after that. So that's why the clinical team is really important in this. If you're going to allow the tech folks and business folks to introduce AI to your patients, you will not have a seat at the table, and you won't be able to leverage the trust factor that you have with your patients, which I think is crucial as this evolves out.
So I'm going to ask you both business questions because I think all three of us are business people. So I'll start with you, Dr. Grasso. Are these two tools best implemented on a systems basis? You talked about trials, and we probably see in this healthcare system, there's a million little trials, but nothing ever turns into anything that's major. So what's the business case you're making with Amelia are you making that case, first of all, to healthcare systems? Are you starting smaller at care groups? Where are you starting the conversation, and how are you creating that demand from a business perspective? What's the value driver to these organizations?
So there's the challenge of the patient consuming these things in an early stage. That's a challenge. There's a challenge of hospital CEOs and C-suite folks that have never done this before, so they have their own risk aversion. So I'm approaching it bottom up. I'm approaching it that I'm doing this in my clinic. I take the risk. I'm the doctor. It's my license. It's a SaaS model. It's secure. That's how it'll start. At the same time, we're in discussions with forward-thinking board members of systems that want to go on the AI journey, and they don't know who to trust, and the consultants want a lot of money, and so there's the dance there. So the top down is get buy-in from the thought leaders in these large systems, and then go phase 1, phase 2, phase 3, and bite off a little at a time. It's really hard to deploy this whole thing, the whole thing, devices, interface, security frameworks, not too easy. So there's a bottom-up and top-down approach that I think will lend itself very well to this.
Same question for you, Aaron. When you think about Pentavere and the tools you're developing, if I'm an executive at UHN, how do you make them care about Pentavere? What's the best deployment to kind of show that proof of concept, and where do you go after proof of concept?
Yeah, in our business journey, we've been quite fortunate that value proposition has been quite clear, because every institution knows the cost to manual chart abstraction. So if you're doing a retrospective study and a contract research organization's coming in, that's an itemized line item that's quite clear and extremely costly. So we're able to very clearly demonstrate you're getting more, you're getting better quality, and it's scalable. So that's how we've introduced from a business perspective. In the case of UHN, they've been investing in a number of tools to deliver very similar to some of the technologies we've talked about today at point of care, and there's holes. There's been holes in that data. So the ability to be able to demonstrate filling that by being able to extract from the unstructured text without incurring those manual costs enabled us to, A, show value early and create a sustainable business model where 1 + 1 = 3 across all of the partners.
Okay, great. We're coming close to 3:15. I'm just going to ask, is there a question from the floor, a burning question you had for our guests? No burning questions. Okay. Here's a burning question. Here we are.
Just one quick question. Is there any distinction that you're making between implicit and explicit communication? That's basically it.
Yeah, so the question was, is there a differentiation between implicit and explicit communication in these interfaces, and how does that work?
Implicit and explicit is kind of hard, right? Especially implicit. What is the intent on what you're going after? So the dance, the black art in designing these forward-facing systems that will engage with the patient, that's going to be domain specific, is to design the questions in the interface so that they kind of stay in a swim lane where you don't get wildly disparate replies and questions, right? Unless you have a lot of interaction with someone, it's hard to really understand what they are implying, rather than just the easiest is a binary answer, yes, no. There's no implicit anything. So that's the dance of how you ask what you expect back, and how well was your machine trained to dance in that environment. That's the black art of it. That's not the easy part. So those things happen in parallel, but that's why computational linguistics and the NLP people and everybody else are involved. This is a team effort to try to get up to a certain level of safety, right? That what you got back is within a threshold of certainty, so you can take the risk and assume that you got the answer you wanted. So that's why the machine learning part is so important, to the iterative part on the back end. So great question.
So thank you to the other speakers, Dr. Grasso, Aaron from Pentavere. Thank you for your presentation, and we'll see you later on this afternoon at the reception. Thank you.
Thanks, man.